Black holes can be one of the most fascinating and amazing features of the universe. Imagine a cosmic void so powerful that not even light can escape its grasp, a being that can crush everything into a single, infinitely dense point. Now the picture finally begins to see one of these enigmatic giants. This is not science fiction. It's a frontier we're about to explore. What is at the center of a black hole? Is it a gateway to other parts of the universe, or perhaps to other universes altogether? The answers are both compelling and terrifying. Before we dive into the seminal discoveries that got us to this point, let's return to the genesis of our fascination with black holes. It all began in 1916, when Albert Einstein's theory of general relativity predicted the existence of these celestial phenomena. At the time, black holes were a theoretical curiosity, their existence only a mathematical prediction. It took another half-century before scientists found the first concrete evidence of their existence in our universe. The breakthrough occurred in the 1960s thanks to the study of the Cygnus X, one-star system. Astronomers have spotted a bright blue star emitting X-rays around a massive invisible object. This invisible companion turned out to be a black hole, a discovery that sent ripples through the scientific community. This confirmed that black holes were not just inventions of theoretical physics, but real objects in space. But what are black holes? These are regions of space-time where gravity is so strong that nothing, not even light, can escape their pull. Everything that crosses their threshold, the event horizon, is destined to be a one-way journey into the unknown. These cosmic giants form when massive stars use up their nuclear fuel and collapse under their own gravity. The resulting singularity is the point where densities become infinite and the laws of physics as we know them break down. The discovery of Cygnus X, was only the beginning. Since then, astronomers have identified more than 100 million black holes in our galaxy alone. Each is a unique puzzle whose behavior can vary wildly. This massive population of black holes increases the interest in understanding their nature and possible impact on our universe. The first clear photo of a black hole, taken in 2021, marked a watershed in our search for information. This image of the M87 black hole revealed a huge vortex of superhot hydrogen gas spinning at an astonishing 1.2 million miles per hour. The discovery showed that black holes are not just empty spaces, but complex structural entities with distinct layers. To understand what is inside a black hole, you have to move through these layers. The outermost layer, the event horizon, is the point of no return. Once you get past that, you are inevitably drawn to the center. The next layer, the photonosphere, is the region where light itself is trapped in the orbit of the black hole. Finally, there is a singularity at the core, where all matter is crushed into an infinitely dense point. This is where the known laws of physics cease to apply. Despite these painful details, each black hole forms a unique puzzle. A direct study of them is almost impossible, because everything that enters a black hole is lost. Instead, scientists study black holes indirectly by observing the radiation they emit and the behavior of nearby gas and dust. These methods, although ingenious, leave us with a two-dimensional understanding of these three-layered giants. The magic of black holes does not end with their destructive power. Some theories suggest that they may be more than cosmic vacuum cleaners. In 1963, New Zealand mathematician Roy Kerr used Einstein's equations to describe a rotating black hole. Kerr's solution showed that a rotating black hole collapses into a ring of fire or a thin disk instead of a point. That spinning disk of matter, known as the ergosphere, would prevent the collapse by adding a stable structure around the black hole. But Kerr's most interesting prediction was the existence of an Einstein-Rosen bridge, or wormhole. Imagine a tunnel through space that connects two separate regions of the universe, or even two different universes. This is an attractive option for wormholes. If you could survive the journey through a black hole, you could ascend to a completely different part of space, or perhaps a completely different universe. The concept of wormholes suggests that black holes are not only endpoints for everything that enters them, but can also be gateways to other dimensions. This idea transforms black holes from terrifying death traps to the most fascinating phenomena in the universe. Could we one day use these space gateways for interstellar travel? It is theoretically possible, but we are not close to realizing it. The idea of traveling through a wormhole is rooted in Einstein's relativity concept of space-time. Space-time is a four-dimensional fabric warped by objects with mass. The greater the mass, the more it warps space-time and creates a gravitational field. Now imagine space-time as paper. If you draw 2 points on a piece of paper and fold it so that they touch, you create a shortcut between them. This is the essence of a wormhole, a shortcut through space that would theoretically allow instantaneous travel between distant points. Although speculative, wormholes are an interesting prediction of general relativity. No one has seen wormholes directly, mainly because they are inherently unstable and collapse quickly. But the existence of the Einstein-Rosen bridge suggests that black holes are more than just cosmic debris compactors. They may hold the keys to understanding the true nature of our universe. Standing on the edge of this new frontier, the mystery of black holes continues to deepen. Theories abound, each more interesting than the last. Could black holes be gateways to other parts of the universe? Could they connect us to parallel universes? Or are they simply keeping secrets about the very essence of reality? One of the most exciting theories is the Kerr wormhole, named after Roy Kerr. This theoretical space-time crossing could connect 2 separate regions of the universe, or even different universes. This suggests that if you fall into a black hole, you might not fall into the void, but instead be shot through a white hole in another universe. This would mean that black holes are not the ultimate destroyers we thought, but rather cosmic gateways to other dimensions. The idea that black holes could be pathways to different parts of the universe, or even to different times, has fascinated physicists for decades. It challenges our understanding of reality and opens up possibilities that were once limited to science fiction. Perhaps in the future we will find a way to harness these pathways and travel through space in ways we never imagined. As we continue to study black holes, we are closer to unraveling their mysteries. Each new discovery brings us one step closer to understanding these enigmatic giants and their place in the cosmos. The journey is far from over, and the secrets of black holes are waiting to be revealed. Who knows what we will find when we finally look into the heart of a black hole? The answers may just change our understanding.
The universe itself, as we delve into the mystery of black holes, recent advances in technology and theoretical physics have fueled our curiosity and excitement. One such advance is the detection of gravitational waves, cosmic waves generated by the most violent and energetic processes in the universe. In 2015, the LIGO and Virgo collaboration made history by detecting gravitational waves from the collision of 2 black holes. This pioneering discovery confirmed an important prediction of Einstein's theory of general relativity and opened a new window into the observation of the cosmos. Gravitational waves later became a powerful tool in the study of black holes, providing information about their properties, mergers, and the extreme environments in which they exist. Another exciting development in the understanding of black holes is the study of Hawking radiation, a theoretical prediction by physicist Stephen Hawking. According to Hawking's theory, black holes are not completely black, but emit weak radiation due to quantum effects near the event horizon. This radiation causes black holes to lose mass and eventually evaporate over incredibly long periods of time. Although Hawking radiation has not yet been directly observed, it provides an important link between quantum mechanics and general relativity, 2 pillars of modern physics that are often at odds. Understanding Hawking radiation may bring us closer to a unified theory of quantum gravity, a long-awaited goal in theoretical physics. Efforts to understand black holes have also led to the study of alternative theories of gravity and the nature of spacetime itself. Some scientists argue that the cores of black holes may not have a singularity, but contain exotic states of matter or even new dimensions of space. These ideas come from attempts to reconcile general relativity with quantum mechanics and string theory. For example, the concept of fuzzballs, proposed by string theorists, suggests that black holes consist of tangled strings rather than singularities, eliminating the paradoxes associated with traditional black hole models. Such theories are still speculative, but they push the boundaries of our understanding and inspire new ways of thinking about the universe. As we stand at the precipice of new discoveries, the importance of cooperation and international efforts in space exploration cannot be overstated. In projects like the Event Horizon Telescope project, which took the first image of a black hole, scientists and institutions around the world collaborate to achieve monumental successes. Future missions such as the James Webb Space Telescope and the Laser Interferometer Space Antenna, LISA, promise to provide even more detailed observations of black holes and their surroundings. These efforts give rise to the collective human spirit of curiosity and relentless pursuit of knowledge, bringing us ever closer to discovering the mysteries of black holes and the cosmos.